Okay, so in this video we'll talk about other forms of player movement. First we'll demonstrate why the when key is pressed is kind of bad. We're going to learn about the say block. It's not actually really used for games, it just can be helpful in explaining things and also just simple mouse input. There's an if statement and mouse down. The if statement is an important statement. We're going to learn how to do key input correctly and then look through the possible movement schemes. Okay, so first let's get the basic when block key is pressed setup. And you may have already realized the problem with this if you've experimented with this in the past. If at any point in time you want to just try things out yourself, feel free to pause the video. Okay. Okay. In case you're wondering, I did do a couple of changes before we began. First, I set the background design different. Second, I changed the size over here. So you can change the background by going to here, choose a backdrop, and I chose XY grid 20px. Anyway, so to give you a better sense of things, every one of these notches is every 20 pixels. So when we hit change Y by 10 twice, we move up 1 unit. Anyway, so moving around with this, you'll discover a few problems. First off, if you want to go immediately to the right and just continue going, that doesn't really work. It has this weird delay, which is a bit of a problem. Also, diagonal movement is impossible. If you go one and then hit another key, it can only deal with one at a time. So that's all the problems with this setup. So let's look into other ways of movement. First, using the mouse. So let's get a good friend, the when flag clicked, and a forever loop, and then a go to mouse pointer. This is a very basic idea. Basically, always just forever go to the mouse pointer. If you have if you want to have your mouse be something different than your standard mouse, then this could be used. There's also a point towards mouse pointer, and this just points towards the mouse pointer. So yeah. Okay, so those are these two basic things. They say what they do. So next, more importantly, is this section, the sensing section. This is where most of the player input can be found. So with the mouse, there's mouse X, mouse Y, and mouse down. Mouse X and mouse Y store where the mouse is. And to demonstrate this, I'm going to need another block, the say block. The say block basically, if it's run, it'll say something and it'll stay there for the rest of time. So, anyways, here we go. By setting this up, this will tell us where our mouse's x coordinate is. 0 in the center, negative 240 on the left, 240 on the right, and here's the y coordinate. It's 180, 0 here, and then negative 180. So yeah, if you for whatever reason wanted your sprite to always So yeah, that's mouse X, mouse Y. Next, by doing something like this, basically this go to negative 123, Y, mouse Y. It's basically saying fix the X position always to negative 123, but the Y position we will fix it to whatever your mouse is at. Similarly, we can do the same thing with X, and this can be used if you had, for example, some breakout type game, or Pong going up and down. So those two basic things. Finally is mouse down. If you notice, mouse down has a different shape than the rest of them, and surprisingly it still can fit into these things, but instead it just says true or false. This shape is it's a boolean, and that basically means it's either true or false. This is used for statements like the if statement. Okay. Or perhaps the if-else statement. The if statement says basically, if this, then that. It's kind of self-explanatory. So, if the mouse is down, then execute whatever's in here. After that, just continue on your merry way. The if then else is the same idea, but slightly different. If this is true, then do this stuff. Then say hello. Otherwise, say goodbye, for example. So, depending on if my mouse is clicked or not clicked, it'll say hello or goodbye. That's how you can use these strangely angled shaped blocks. So that's dealing with this mouse down and ifs. Mouse down isn't the only thing that has angles, that is angled and is useful for player input. For better key input, we should use the key blank is pressed. If, for example, you have if key right is pressed, if key right is pressed, we want it to move to the right. So that's that. Now let's duplicate it, and now if it's going left, let's make it go left. Duplicate it one more time. If key up, change Y by 10. Last of all, if key is down, change Y by negative 10. Stringing this all together. Now, and resetting it so it doesn't say anything. Now we have a lot more smooth much smoother control. What you might notice though is if it's going to the left, it doesn't actually face left. So let's fix that. Let's make it point. Okay, so 90 is facing to the right. So when we want it to face to the left when the arrow key is pressed. If you run this though, well, one thing is it's upside down, which is annoying, and the other thing is when going back to the right, it doesn't point to the right. So let's fix that by adding this right here. So now we've got it so it looks kind of okay, except for the fact that it's upside down. To fix that, there's a set rotation left-right thing. You can also change it by going over here, this, and this. So, okay, to demonstrate these different styles, let me just create a new little forever loop here, and this. And we're going to use the point to mouse pointer. So if it's all around, it's, well, looks like this, which is, normal, expected. If you change it to left-right, it reflects. It only either goes to the left or to the right. Finally, if you set it to don't rotate, there's no difference. No matter what direction it's actually going, it always looks the same. With that in mind, to fix the weird flippity-floppity, we can just simply set rotation style to left-right. And now, it works as expected. To change the speed, if you don't like how fast it's moving, you can just change X bys, and change num to like a smaller value, like 5 for example. So now it moves not quite as fast. So that's your standard movement scheme, but that's not the only one. Another one that I like to use sometimes deals with direction, and it's more for top-down perspectives. So let's draw this circle. Or here's a neat trick: if you hold shift while drawing a circle, it will make sure it's perfectly a circle instead of just some oval or something. Give it some eyes. And there we go. This is just to demonstrate a top-down perspective. Oh, let's make this bigger. So another format is instead using the setting rotation style to all around and using the turn and moves. So if it's left, we turn counterclockwise. If it's right, we turn clockwise. So now, let's start the green flag so it actually runs the script. Now, left turns it left, right turns it right. If you're wondering why it's wobbling a bit, that's because in the costume there's there's a center point, and if it's not exactly on the center, it doesn't work. So yeah, I'm a little too lazy to make it perfect. Anyways, so that's that, and then after that, we can use the move 10 steps. So now you can just, it's honestly pretty fun with this movement system. So yeah, and then if you hit down, move negative 10 steps. So this is like a top-down perspective type thing. It's pretty fun. So those are just 2 examples of what you can do for movements. It's up to your imagination to implement other ones. So yep, that's it for this video. Thank you.